In applying substitution method, suppose you're interested in calculating the integral of x squared divided by square root of 2 plus x cubed dx. So take a look at your denominator. The quantity inside the radical is 2 plus x cubed. We're going to take this guy and use u-sub. So let u to be 2 plus x cubed. If I take the differential of both sides, du becomes 3x squared dx. So dx is equal to du divided by 3x squared. Remember that we have x squared dx here. That's why you can write dx as du divided by 3x squared to cancel out x squared. Otherwise, if the x squared is not in your integral, you are not allowed to use substitution like this. It's wrong to create a new variable. So this can be written as the integral of, so I'm going to write down everything, x squared divided by square root of u, and instead of dx, I'm going to write down du divided by 3x squared. Okay, let us simplify this as much as we can. X squared and x squared, they get canceled out. So this can be written as the integral of du divided by 3 times square root of u, which is familiar to us. Why is that? First of all, from algebra, remember that the square root of u is u to power a half. And if you have 1 divided by square root of u, which is 1 divided by u to a half, it can be written as u to power negative a half. You can take this quantity, which is on the denominator, write it on the numerator with negative exponent. So this integral can be written as a third integral of u to power negative a half du. We saw this integral before. The integral of u to power n du is u to power n plus 1 divided by n plus 1 plus constant of integration. This is a familiar formula. We're going to apply it here. If we have the integral of u to power negative a half du, your n is equal to negative a half. So it becomes u to 1 minus a half divided by 1 minus a half plus constant of integration, which is u to a half divided by a half plus c, or 2 times square root of u plus c. Take this quantity and replace it here. You have a third times 2 square root of u plus constant of integration. Are we done yet? No, not yet. Why? Because my u was 2 plus x cubed. I have to replace this guy back here. My original integral is in x, not in u. So this guy becomes 2/3 the square root of 2 plus x cubed plus constant of integration. Our next question is the indefinite integral of x plus 3 divided by x squared plus 6 times x to power 2 dx. Very good. So we have a quantity on the denominator. It has higher power, x squared plus 6x. So I'm going to take this guy in an attempt to use substitution. Let u be a new variable, which is x squared plus 6x. If I find du, it is 2x plus 6 dx. Okay, can I factor out 2 here? Of course. du is 2 times x plus 3 dx. Well, I have x plus 3 dx here. What I can do, I can multiply and divide by 2. 2 times a half. Then I can take all of these quantities on the numerator and call it du. So this guy can be written as a half integral of du divided by u squared, which is familiar to us. If you don't feel comfortable about this method, you can just basically write down dx as du divided by 2 times x plus 3. So let me write down or here for you. If you have the integral of x plus 3 divided by x squared plus 6x to power 2 dx, when you take u to be x squared plus 6x, as we saw, du is equal to 2x plus 6 dx. So dx can be written as du divided by 2x plus 6, but make sure to write it in factors form. dx is du divided by 2 times x plus 3. So your integral becomes the integral of x plus 3, and instead of dx, write down du divided by 2 times x plus 3, and on the denominator you have u to power 2. Now you can cancel out these common factors, and this guy becomes the same as the integral that I wrote down on top for you, the integral of du divided by 2 u squared, or a half integral of du divided by u squared. We already know how to deal with this integral. It's basically the power rule. Since the integral of u to power n du is u to n plus 1 divided by n plus 1 plus c, the integral of du divided by u squared can be written as the integral of u to power negative 2 du, or u to power negative 2 plus 1 divided by negative 2 plus 1 plus constant of integration, or negative 1 divided by u plus c. So let us take this quantity and substitute it here. You have a half negative 1 divided by u plus constant of integration. But remember that u is x squared plus 6. So 6x. So you have to substitute this guy back here. You have a half times negative 1 divided by x squared plus 6x plus constant of integration. You can also simplify this way as negative 1 divided by, multiply the fractions 2 times x squared plus 6x plus constant of integration.